one is a light source, right? That's, if we start out in the pathway, we need a light source. That's the genesis of vision, anticipating a light source. The light source comes in. Step number 2 is it hits the cornea. Right? So light source 1, cornea 2. 3 goes through the aqueous chamber. The aqueous chamber is the cavity between the cornea and the lens, right? Goes through the aqueous chamber. And in the aqueous chamber we have what?
Aqueous fluid.
Aqueous fluid. It goes through the aqueous fluid and then hits the lens, right? So the lens would be step number 5. So we've gone from light source through the cornea, through the aqueous chamber, through the aqueous fluid. We've hit the lens. What happens when we hit the lens?
It gets refracted.
Refracted where? But we got a one step before we get back to the retina through the aqueous chamber in the aqueous fluid. So we're being refracted back, the light source refracted back to what? Step number 7 would be the ganglion cell, right?
Right.
Nothing happens. Step number 8, bipolar cells, nothing happens. Step number 9, photoreceptors. That's the magic moment. That's the magic moment when the light source now becomes a neuronal impulse, because the light source will stimulate the rods and cones. And the rods and cones are the photoreceptors. The photoreceptors are found in that third back layer of the retina. Okay? Remember, the retina is this whole part here. We got the 50% of the retina is this back end green area, which is the epithelial retina. Okay? 50% of the retina is this front part of the retina, which is the neuronal retina. And the neuronal retina, which is 50% of the retina overall, is divided into 3 divisions: ganglion cells, bipolar cells, and photoreceptors. Okay? So this is only 50% of the retina here, and you take this 50% and you divide it into 3 parts, and you have your ganglion cells, your bipolar cells, and your photoreceptors. So the action potential occurs when the photoreceptors, the rods and cones, are desensitized. So they're stimulated, they come back out now as it goes in as a light source, right, hits the photoreceptors and is changed to a neuronal impulse, and now it comes back out. So the photoreceptors synapse with the bipolar neurons. So step number 9, number 10 becomes bipolar cells again, or bipolar neurons. Step number 11, the bipolar neurons synapse with the ganglion cells. So ganglion cells are step number 7 going in, number 11 coming out. Ganglion cells coalesce in step number 12, which is what? Optic nerve, right? The optic nerve. The optic nerve leaves the eye. Okay, so optic nerve 12 goes to the crossing over part, which is this area here. That's the chiasm. So that's 13. The chiasm forms the 50% fibers go to each half. Forms 14, which is the new optic tract now. This is the optic tract. Optic nerve, crossover, optic tract. Lateral geniculate body of the thalamus becomes step number 15. Leaving the thalamus, we get into the tracts called the optic radiation, is 16. And then 17 really is the occipital lobe of the cortex, but we could make 17, 18, and 19 if we really wanted to get particular about it. Okay, so when we go from number 1 light source to occipital gray matter in the cortex, step number 19, that's the pathway of vision. The pathway of vision starts with an environmental stimulus, converted to a neuronal impulse. The neuronal impulse goes up the brain to the cerebral cortex, into the occipital lobe of the cortex where the vision is perceived. And then what happens? Then what happens? Once we get to that gray matter in the cortex, right? It's great to get there, but
association
kind of
neurons, association
neurons, interneurons, right? They call them interneurons or association neurons.